I'm going to make a statement and you have to tell me in the comments whether you agree with that or not. All large language models are foundation models, but not all foundation models are large language models. You have to comment down below, take a pause, think about it, and just say whether it is true or false. Hey everyone, welcome to my channel Code with Ease by Varsha. And today, as part of the AI engineering, everything that we are hearing about AI engineering, as part of that, we have started on this channel talking about the same. So, the first video we have put up is around AI fundamentals, the jargons and terminology, how the concepts of AI that you hear of every single day connect with each other. So, that was the first video which we had put up. Second video was more for the Java developers, for the backend developers, Spring Boot developers who were thinking that they are not going to be relevant in the AI era. But the plot twist is they're going to be even more demanding. They're going to be in more demand these days. And we talked about the AI integration patterns, the practical next steps which Java backend developer needs to take to be able to integrate AI models effectively and thus build production ready applications. So, if you have not watched those two videos, please do because we are going to continue from there. Now, the reason why I made that statement at the very beginning is because the world is slowly or has already shifted towards agents, multi agent, agentic systems. But this thing around LLMs and foundation models is something which is actually the foundation of everything and anything that you need to learn about AI engineering. So instead of chasing the next shiny big thing, it is important to clear your fundamentals first and then move on because whatever is there in the history is going to be again taken forward. So if you do not know essentially difference between LLMs and foundation models, you are essentially not going to be able to work with agents. And today in this video, we will of course talk about what are AI agents, why do we even need them, what qualifies an AI agent. But today we are also going to talk about the evolution of what actually happened with foundation models. The framework that we are going to use for Java backend developers, Spring AI, why do we even need that? We will also discuss about the learning path, which many of you were asking for in the community poll. So I've created a learning path which the backend developer needs to know so that you can tell that once you have completed that learning path, you can say that you are confident enough to say that you know things, how to actually work with production workloads and integrate AI with that. So, quite a few things planned for this video. I'm thinking of doing like a multi-part series with the relevant topics around the same so that you are equipped with the right knowledge. And so, with that being said, without further ado, let's begin. Okay, so now let's get started with what is the problem of foundation models. Remember the question which I asked at the beginning. So LLMs are a subset of the foundation models. LLMs work with only text, foundation models will work with different other types like images, video, data, text, everything. So since LLMs are a small part of it, that is why LLMs are foundation models, but not every foundation model is not an LLM. You need to understand this is because everything has a problem, which is why we are moving towards the next. So generative AI, the world of Gen AI, foundation models, LLMs have intrinsic problems of their own, which is why we started to move towards agents, agentic systems, multi-agents. So we have to first, if you don't understand the problem, it is as simple as jumping on the next shiny thing. So you first take it step by step. First understand what were the problems that we are trying to address, and then we will start getting our hands dirty about building those for our production. So the problems are very simple. So first, contextual awareness is not present. Secondly, we need external memory. Of course, with whatever memory is being there, that is going to last for some time. But is that enough? No. The concept of databases have also come in. So anything when you're trying to deal with enterprise grade, you need external memory, and that is where concepts like RAG and knowledge bases have come in. Okay, next is, of course, the same thing that it will have very generic information about the data it has been trained on, and it has obviously been not trained with your private data or your business data, right? So it will not have any information about that. And if you want anything customized, you will not be able to get it done with the foundation models. Real-time access is not there. There's a knowledge cutoff. We all know that. And this is the most important reason. I think it is the reason why agents have come in is because just by using foundation models alone, you will not get any work done. It will not be able to execute things. autonomously or semi-autonomously, will not be able to perform any action. So all in all, these are the basic reasons why if we want to integrate AI with our business applications, we cannot just have foundation models. We cannot just be stuck in the world of Gen AI. We have to move ahead. With that being said, now the question has been that why do we even use Spring AI? I think the very simple answer for this would be the reason the world shifted from Spring Framework to Spring Boot is very simple reason why we are not shifting from Spring Boot. We are basically adding on Spring AI to that because your enterprise systems are already deep rooted in that particular, let's say, microservices architecture already, which has been using Spring Boot, Spring Data JPA, Spring Cloud, or let's say Spring Security. It's already deep rooted, embedded in this ecosystem already. And to improve our developer experience, we're definitely not going to rewrite things. Now, if you look at this image, this is the core fundamental image of the Spring AI documentation. What it says is you have your enterprise data and your APIs on one hand, and you want to integrate AI with that. So Spring AI is giving you that bridge. It's giving you that very simple, no nonsense, intuitive framework, which is going to help you to build the bridge so that you can connect it all together. And as a result of that, it is basically making it very Spring native. I said deep rooted in the ecosystem, opinionated framework. Auto configuration is already being taken care of, improving developer experience. It is already deep rooted. So if we want to keep our Gen AI Spring native, this is a very simple. Spring AI is facilitating that, addressing the fundamental challenge of integration of AI with your enterprise data set or with your enterprise ecosystem already, which comprises of your data, APIs, code base, and everything, microservices, and all of that, everything, with the external AI models. So I hope till this point it is clear. Why are we using Spring AI? If not, so let's go further into this. Now, RAP's complex AI models. So my take on this is when Spring AI was not being developed, 2 to 3 years back, when we were trying to do an OpenAI API call. It was all about the low-level API calling, and we became very happy while we bought the API key and we integrated our first Hello World code, and we used OpenAI key and made the first API call, and we got the response. Very very cool, very fun. But then as the system matures over time, and then more and more model came in, the concern was that if you have to do this low level API calls all by yourself and doing this, imagine doing this across a massive code base. Is it going to be scalable? Is it going to be reliable? Again, the production grade concerns. So this is what Spring AI, by giving us the complex abstractions, it makes this easier for us. First. Second is the idiomatic or the opinionated framework which we already have. It just makes it by using Spring AI and the classes that we are going to see, it just makes it very easy for us to integrate that by using the wrappers or the abstractions over it. And because it is the same ecosystem that we are using, we're already familiar with the annotations that we are going to use for doing the integrations. So nothing groundbreaking is happening over here. We already have been doing this. It's just that we have to do it with the new functionality or the new library which is provided with us. Simple configuration changes, nothing to rewrite as developers. And what does production grade or production readiness features mean? Error handling, retries, transaction management, security, observability, resilience patterns, your microservices patterns that we need. Very importantly, about AI models around getting hallucinated responses and how can we prevent that from happening. So we need to evaluate the responses, right? So all of these things are real concerns. And to address all of these, we definitely need Spring AI, which gives us with a very simple, like ready-made classes to use all of this. So you basically need to integrate AI into your production applications. You have to worry about the business logic, about what my custom use case is, rather than you having to worry about the underlying implementation of the API, because you worry about what revenue can your application now generate after integration of AI. I mean, revenue generating or cost optimization, whatever your use case be. So that is what you as a developer have to worry about, nothing else. So I've divided this into two parts. One is core capabilities and one is the enterprise grade features. So core capabilities we already talked about, like when you're using Spring AI, not every model is going to give you all the required use cases. So you have to maybe switch between multi-mode models. You may have to switch between that. The output that we usually get from AI responses is usually in string. And in most cases, or almost every case, we have to map that to our Java class, the Java objects, for for better business integration. So that is something which you can be doing it. We need real-time access, so we would be doing tool calling. Function calling is as good as calling a third-party API. So that is there, and advisors are actually very useful because if I have to add memory or RAG capability to my applications, doing it again and again is very cumbersome. So in as we go through the series, when we talk about advisors, we're going to see how it makes it very easy. Like in the configuration class, you just have to define it and it is going to be valid throughout the life cycle. So these are the things around the core capabilities and enterprise features we talked about, right? Of course, vector store integration is as simple as in my previous videos I was taking. At some point, we were learning about JPA, working, integrating NoSQL or SQL databases into our applications. Now it is about the vector stores that we have to integrate. There are so many varieties. When to use what? That is the concern. How to use is not the concern. When to use what is the concern. MCP support, needless to say, not going into that. It's a very high level thing right now. We'll slowly uncover everything. Guardrails, when we talk of secure or responsible AI, it's a matter of business reputation. If I ask something political stuff to the agent, uh, it should not it should not answer that to me, or it should not give me biased answers. So responsible AI guardrails is a thing. Observability, because we want to monitor how the responses are coming. Evaluators, I mentioned, right? The answers can hallucinate. So how are you going to evaluate if that is up to the mark? And auto configuration, I really don't have to say. The starter projects which are created or being made available to us is what is going to give us the best starting point to get started with. So apart from this, if you want to read more about the features, what you can do is, this is the Spring AI documentation, as you can see. Scroll down here, and this is where you will see these are the following features. So I've just got a quick glimpse of the things which are happening, but again, a deeper dive, and if you need, you can come here and check it out. This is like your Bible or your North Star. You have to go through this or get yourselves comfortable and familiar with this documentation. So now let's understand about what is an agent, why do we need it, why do organizations need AI agents, and what does or what qualifies an agent to be called as an AI agent. So let's look into that first. Let's try to understand what is an AI agent. So I have this very simple mental model which I call the RPAG framework. Just the initials to help me understand or help me explain what is an AI agent. So firstly, AI agents are autonomous or semi-autonomous software systems. Why do we call autonomous or semi-autonomous? Because we're trying to make the human in the loop thing minimal, as we are trying to reduce the human intervention, but we are not completely getting rid of human intervention. So these software systems who can, one, reason, two, plan, three is act to accomplish goals. So that is why I call RPAG: reasoning, planning, acting, and then goals. So how I think of it is that, like, whenever I have a goal, let's say I have to let's say I have to lose 10 kilos in a year. So this is my goal. But for doing that, do I lose 10 kilos in a month or two? No, it's in a year. And I have to break it down into smaller goals. I have to decompose a bigger problem into smaller sub problems. So that is why this is where the reasoning comes in. And then the next step is I have to plan my diet, I have to plan my workouts, I have to plan my sleep, I have to plan my lifestyle around it. So reasoning, the planning. And then not just planning, I have to act on those also. That is why I said that this framework is what is very important for you to understand what actually qualifies an agent or an AI agent. Now, with that, let's try to understand what do we have. What are the main responsibilities? Like I said, first, it needs a reasoning engine. So to reason with it, like for doing the when I said reasoning, what I mean by that is, if it has to actually validate some work that it is doing, it needs to query the existing knowledge base. And that is where foundation model will have a role to play. The reason because it needs artificial intelligence still. So that source is being given by the foundation model. So first is it needs the reasoning engine. Using that reasoning, by using that intelligence, it is now going to break down that work into smaller subtasks. Then once that is done, now for uh, the contextual awareness, or for retaining that, it needs external memory to be added. Then we have tools, because remember, foundation models do not have also access to real time data. So for external integration, we need tools, so tool integration. And finally, it has to learn and reflect. Very important, the concept of reinforcement learning, or the concepts of evaluators also, which comes in, because everything that is done, it also has to judge itself, that have I done the correct thing. If it not, it is going to redo this entire. So the thing, why it comes like a loop, it's a cyclical thing. It has to do it again and again, again and again, until it reaches the point where the human being just says that yeah, it's okay now, now just go ahead with it. So at the very fundamental level, this is what AI agents are supposed to be doing. Only then we can call them an AI agent. Why do organizations deploy AI agents? On a very high level scale, these are the reasons. Like I said, it can be to boost revenue, generate revenue, it can be cost optimization also. Productivity boost is also like, again and again, if you're doing things, redundant task, so that it is going to reduce that repetitive work. Cost reductions, inefficiencies, getting rid of that. Massive real time data. So yeah, I mean, as a human, I was reading somewhere like the work of consultants requires, like for example, a lot of R&D around the sector or the industry that they want to work on. So it's like massive data already. So if you want to get strategic insights, which is going to be of some value, how do you do it? Use the agents. Like very simple example can be like Reddit threads that you want to skim through those, and you want to get insights out of those. Build an agent for that. Um, Next is the customer experience. I think this example I gave in my previous video about the different use cases also, that how many food ordering apps are now adding agents. It's a completely different story, that the refund and all is being processed in a very unoptimized way, but that is a use case. And consistency, because proactiveness is a thing. Like if the changes are happening, the agent should be able to autocorrect and get it back on track. So like on a very high level, we can go into a very deeper level also, but on a very high level, these are the things which you can question at your organization level, that whether do we need an agent. If it ticks any of these boxes, is when you can say that yeah, it makes sense to use an AI agent. So now with that, we will move on to the mind map, that as a Java developer, what is your learning path going to be around this? So this is the learning path which I was talking of, that when you are going to build AI agents in Java using Spring AI, what are the things which you have to know? So this is from like this is sort of like the roadmap which you need to know, or rather a mind map, because it has branched out in different ways. And let me tell you step by step. So the first thing is the prerequisites, which you have to know. Of course, you need to be in that particular framework and ecosystem. So you have to need to know the framework. Uh, and if you're a backend developer already, I'm assuming you already know and you have the skills. So once that is done, the next thing which I talked about at the start was about the challenges, why foundation models, like the problems with the foundation models, basically, what were they, and why eventually we started gearing towards having agents. So then after that, you have to understand what are the core components. So of course, for building agents, there are multiple frameworks, and we are going to be using we are going to be using Spring AI. So Spring AI framework, I talked about the documentation which you have to refer to. And with that, the abstractions or the wrappers, like I said, like Spring AI offers the wrapper, so that you don't have to do the low level API call. It has given us chat client for that. And Amazon Bedrock integration or the cloud provider integration, whatever suits your business need, so that again, you don't have to do the low level API calls. It gives you a single unified interface, and it's a managed service in itself. So these are like, again, the building blocks which you have to know of. So once that is done, then the capabilities of the what makes an AI agent an agent. So these are the things which qualifies to be called an AI agent. The same. So the contextual reference, then conversation memory, knowledge base, ability to call tools for real-time information, and MCP integration. So these are the things. So when I say these things, basically you have to, like, along the way, we are also going to learn about how each of these are being done in, like, programmatically. We know the concepts of this, but then how can we actually do that programmatically, and what are the trade-offs that can happen? So with that, we also have three things now remaining. Now that is the production readiness of it. So security, and then the deployment. So in production readiness, like I said, couple of things are there, but the most important thing is, like, after deployment you would want observability to be there, and when you're coding you anyway have to deal with the error handling, retries, transaction management, design patterns, distributed, just as we have design patterns, distributed systems patterns. So that will come under the production readiness. So once we have done that, we have a couple of deployment options. I'll come there. So security and authentication. Actually, security first, like when you are actually building agent, the first thing which you have to take care of is security. So that is a very, very important thing. Even before you think about deployment and stuff, security first. And when we talk of security, we are also nowadays talking about building agents with the correct guardrails, building secure agents, building responsible AI. So that also has to be factored in. And finally, we have a couple of different ways in which we can deploy the agents in runtime. We are going to see all of that as well. There are a couple of different options. You have to choose whatever suits your need. So pretty much this forms the roadmap, sorry, the learning path, rather, that what are the things which you have to learn basically to be able to build Java AI agents. And yeah, so with that, now let's move on to the code, where we are going to now write and see how we can build our first agent. So we'll now do this little hello world. So we'll now build our first agent, which I call the hello world agent. We're going to use three different approaches. So all of us, I think most of us already, when we integrate or build our first agent, we get the API key of OpenAI. I think that is like the very basic project that everyone does, right? But what if you want to do a local development? So let's talk about that. Integrating with OpenAI by getting the key is something for that you have to anyway purchase the key. But what if you can do it locally by using the open source models available? So let's see how can we build an AI agent by using Docker. We'll pull the open source model from the Docker. So for that, you would need Docker Desktop first. So let's take a look at the Docker Desktop. What are the available models and what are the settings that you need to do for that? And before that, when you are getting started with building your project, you already know the quick start, right? So if you do not know how to do a quick start with a Spring project, very simple, spring.io. And you can choose your Maven or Gradle, the language. Recommended to use 3.5.10. This is what I use. And then, more importantly, apart from these, is the dependencies. So you have to use the web dependency. And for the starter projects, so now there are so many SDKs available. So to keep things simpler, we'll go with the OpenAI SDK. And if you need dev tools, you can use that as well. So on a very basic level, these are the dependencies that you have to use to get started with. Now, when I say local development, what I mean is, uh, instead of paying for a model, how can you make use of the open source, open weight models and start playing around with that? So with that, let's go into Docker Desktop. Should have it open running. So on the left hand side, you can see there are models. These are all the models. So let's say there's a model called Gemma 3. Simple chat functionality. Apart from that, you have other models also. And one more thing which you have to ensure when you're doing this is you have to go to settings, click on the Docker, on the AI, and you have to ensure that the Docker model runner is running, and this is the port on which it has to. So now let me get into my IntelliJ and show that to you how we can integrate that. And one more thing you can also try out on the terminal is you can just do Docker run and then just mention the name of the model. Since it is not able to find it locally, it is now going to pull the image. So once it is pulled, it's going to take some time. It's like almost 2 GB or something. Then we can just query it over here and just to see if the model is giving us the response. So while that happens, I'll show you with the pom.xml. So again, the web starter thing that we added, OpenAI, Spring Boot starter. So these are the dependencies which I've just shown. Then in the application properties, some of the things which you have to add over here. First is the model that you're using. So we are using this particular model. And the API key. So these two, 5 and 6, is something which is needed when you are going to integrate it with OpenAI. But since we are not, so the key can be dummy. And this base URL is just for the auto configuration thing to be satisfied for. So these two things which you have to add over here, otherwise it's going to throw errors. And now when we have these two things, let me show you the controller. A very simple controller that we have over here. But what are the things that we have done? Here we have used a class called chat client. Remember, the reason why we are using Spring AI, chat client is given to us by the by the Spring frameworks, the starter. Let me just show that to you. It is coming as part of the Spring AI core. Okay. So these are the classes which fall under org.springframework.ai, under which we have chat client. So for conversational AI, this is the class which we are going to use. So if I just look into this class, there are two important classes. In the next video, I'm going to talk a bit about chat client and chat model also. But for now, for the implementation, let's talk about this chat client, the abstraction, the wrapper that we are using. And we are just simply using a get mapping. So two things here. When you are using this particular bean, the chat client here, we are going to take in from the user the message, which is going to be the prompt, and we are just going to call it and get the content in the form of a string. Very simple calling of the model and just interacting with it like a agent. So with that, so let me just put a debug pointer over here. This is the main class, and let's try to run this. Okay, so the server has started on 8080. So now let's go ahead and hit this endpoint. So I'm just going to ask, who are you and what can you help me with? So you see that here the breakpoint we have, this is the message, who are you and what can you help me with? This is the default chat client request. Interesting thing is here, the chat model that we are using, you can see that it has populated the model by reading it from the application properties that we are using. Gemma 3, the temperature is 0.7 that it has taken. Okay. So now let's release the breakpoint. Now, talking about local development and taking it one step further, there's something also that we use if you are trying to do it privacy first way and we want the data to be secure enough that it is only available in our local is we use Ollama. So you can set it up Ollama. How can you do it? You can just download the model. So this is how you can do it. And these are the models. You just have to click on download. And then it is going to set that up. So these are the different models that you can pull. Basically, again, the Docker pull is going to happen. So for me, how I have done this is I've just mentioned over here Ollama run Gematria. Let me try to use something else. Ollama run. Let's say we want to run this Llama 3 model. So now it is going to pull that image. And now when we have it, so I'm just going to say, who are you and what can you help me with? So you see, this is coming from Meta, and these are the questions. So now when it is running, it's like running the model locally. You can do customizations, you can keep your data secure. So this is again another way of doing local development. So for doing this, if you want to have an agent interaction, same stuff. Only thing is that the starter project is going to change. So it's going to be Spring AI, Ollama, Spring Boot Starter. Rest everything remains the same. In application property, so in case of the Docker, we had something like Spring AI. This was like chat options. So here the property is little different. It is Spring AI dot model.chat. So we are going to mention it's Ollama. And over here, we are specifying the name of the model. And the controller will look exactly the same. So with that, now let's try to run this locally and see. Yeah, so the server has started already. Again, you can also add debug pointer and just see how you're going to get the response for this. So this is how we have done the integration with two ways, by using a Docker container directly by pulling it, and via Ollama. The third way is by using cloud providers. Why? Because first is your application in general is anyway going to be aligned with any of the cloud providers. So I'm going to use AWS here for an example. So if it is already hosted and it has the necessary integration already, it makes sense to use a cloud provider which is going to give you a unified access to all the different models, so that you just have to write one code and you can switch between models. So what are the reasons? Why am I going to so let's quickly take a look at the different deployment contexts which I was talking of. So whether you are using Docker or Ollama, the goal is you're not going to pay for any costs. You are keeping control to yourself. You are having the privacy first architecture. So it's good for like POC, prototyping, keep it in your local. But again, ultimately the goal, if you're making it production ready, cloud native development, if you're doing, so you anyway have to start thinking about using cloud providers. So, what is the easiest way that you can do? When I talk of cloud provider like AWS, we have Amazon Bedrock. So, the reason why, number one, it is a managed AI service. So, it is giving you a unified API access to multiple foundation models. And not just that, if you're writing the code and you're very, very, think of it like the tight coupling concept. If you are tied to just one model, tomorrow, if the model does not support, or if anything you want to change, if you need, how easy it would be if you could switch between different models, or if you had more flexibility. So that is one thing. So model flexibility. Enterprise features, which we will talk about, that is what we have. For example, guardrails, very important. We already have the support for that. And the API is very simple. Like the Bedrock Converse API is going to it has all the best practices that you need. So integration with that is very, very simple and easy. So let's take a look at how you can do it. So for that, first things first, again, documentation. So let's go to the documentation. This is the Spring AI Amazon Bedrock integration. So over here in the getting started part, there are simple three steps. One is we will see the starter project which we have to add. But the second thing is about the credentials. Secure environment. If you want to understand how enterprise grade features can be used, security is a big concern. So you are anyway going to build this by keeping production readiness in your mind. So obviously for doing that, you have to keep security in your mind also. So AWS credentials tightens this security credential part, and you do not have to worry about your data or your application being exposed in any way. So credentials setup will not take them more than 5 minutes. So it has. I'm going to link this documentation below, so you just can do the quick setup if you're interested in learning how to do this end to end, which I'm showing it to you. And now, with that being said, once you are ready, let's go into the IDE. And first, let me take you to the pom.xml. Everything remains the same. Again, the starter project is different. So, like I was saying, the starter project, the auto configuration part, just as we have in Spring Boot, similar we have over here. So the starter projects are different for every model or for every integration point that you have. So for Bedrock, we have Bedrock Converse APIs. All the APIs which you need to converse with your agent is being encapsulated over here. So this is the project starter project which you have to use. And nothing else, everything else remains the same. Next is about the properties. So where do you get these properties? Documentation. Scroll down, these are the properties that you have, and these are the properties I have kept. I've kept it the India region, the Mumbai AWS region that we have. Over here, when you will do the credential setup, you will anyway get hold of the access and secret key. These are sensitive credentials, so you should not store it. It should either be stored in some external key store or in your environment variable. I'm storing it as an environment variable. Next is these two properties. So the model is Bedrock Converse. Fun thing here is this API, which I mentioned, the Bedrock Converse API, it's like a unified thing, right? So no matter what type of model you are calling, here I'm using the Sonnet 4, the Cloud Sonnet 4, or if I use OpenAI model, or doesn't really matter what Llama or whatever model I'm using, the API, because it's unified, the same code, the code will still remain the same. It's more about a tweak in the configuration which you have to do it over here. So that is it. That is the only thing which you need to do, and you can keep on changing your models. So with that being said, these are the properties and the pom.xml changes. Everything else again remains the same, the controller and everything. So you see the uniformity, the consistency across. And with that, let's then try to run this. Let me just quickly check if I have the environment variables added over here. I think I have. Let me, okay, let's test this. So the application started on 8081. So now we are using Cloud Sonnet 4. By saying that it is the Anthropics model. Oops, I think something to do with my secret and access key. Let me just export that. Cool. So the application is now started. Let's try again. Yes, so we got the response, which means fine. Again, same thing. Add your debug pointers and try to see how the request is flowing end to end. So with that, now you have actually learned how to build your first Spring AI, or rather your first agent in Java and Spring in 3 different ways. And this is the first building block, the first starting point, which you have to do so that we can keep on adding to the functionalities and learn how to build production ready AI agents in due course of time. So with that, yes, we are done now. And thank you so much for watching this video. And stay tuned for more videos that are upcoming in the series.